Hello, everyone. Welcome to the MIT Mobility Forum. This is the episode 143, designed by the MIT Mobility Initiative. I'm Jinhua Zhao, Professor of Cities and Transportation at MIT. Today, I'm really excited to have Professor David Mindell join us to share with us his latest thinking on the new Lunar Society, an Enlightenment guide to the next industrial revolution. I want to make 2 points before I give the forum to David. The first one is, I think the topic couldn't be more timely. Today, I would say higher education or as an institution or science as a community is really under attack. The notion of science doesn't matter, right? So I'm really glad that Professor David Mindell, as one of the really deep thinkers in this, to share with us why Enlightenment thinking is particularly important today. Professor David Mindell will share with the stories of James Watt, Benjamin Franklin, Josiah Wedgwood, in parallel with those of current moment of crisis, particularly to introduce a new notion of industrialism. What does industry look like when it strives to optimize for lowest carbon footprint, as well as make profit? When it values resilience as much as efficiency, when it upholds dignified, inclusive, and sustainable work? And how does mobility provide a fitting example to discuss many of these general principles? The second point, I want to mention that this is actually the fourth time I invited Professor David Mindell to join this forum. He really holds a record on this, right? But why? Let me actually share with you all the talks that David gave in this. So today we have this a new Lunar Society discussion, his new book. Then if you notice, previously also David talked with us on the tectonic shift in science, technology, industrial policy. Previously, we also have discussion on the regional air mobility, initial thoughts. And the first one he gave is on the micro-location transit. You can see that David really covers a variety of different important topics. So I wouldn't read David's bio in this, but I want to say, not only David shared this grasp of knowledge, but particularly has a similar way of thinking that the Mobility Initiative really appreciate. That is, bring the technology and the humanity thinking together, bring the history to bear with today's issues. Lastly, I want to reinform the norm of this forum, which is everyone contribute one idea. Particularly refer to the audience. Please type into the chat one comment or question to Professor Mindell's presentation. Without further ado, let me pass the forum to Professor Mindell. David, please.
Thanks, Jinhua. It's great to be back here again. I actually hadn't been counting, so I didn't realize till just now that this is the fourth one. Although I think the topic is quite connected and quite similar, and all the three previous topics are kind of incorporated into this book in one way or another. You know, I just sort of said hello to Dan Roos, and you know, one of the connecting themes is industrial systems. That's really the term that I used for the topics that I think about. And a lot of it is manufacturing. There's a lot of focus on manufacturing in the news, and it's very important, and it's a key part of it. But as you all know, there's no manufacturing without mobility, because parts got to come from somewhere and they got to go out to somewhere. And logistics, mobility, food, electric power, information systems, these are all, this book is really about the industrial systems that support and characterize what it means to live in an industrial society, which we all do. Let me do my screen share here. Okay,
yeah.
That come out okay?
Yeah.
Title of my talk is the title of my new book with the MIT Press, The New Lunar Society, an Enlightenment Guide to the Next Industrial Revolution. I don't think it's too far to say that the Mobility Forum is a form of a new Lunar Society as well, although one guideline may be the importance of the basic sciences to the conversations, and one interesting thing to think about. As Jinhua mentioned, I've worked on human relationships with industrial systems for my entire career in one form or another, from space flight to robotics and autonomy, which is the world that I've worked in as an engineer. And this book is really a kind of encapsulation of what I've been thinking about and seeing and talking about in forums like this around MIT and elsewhere for the last 4 or 5 years. It is a book about history, and I'll talk about that, but it's also about everything going on today. In fact, the book is 45 short chapters that alternate between the 1750s, the middle of the 18th century, and the present day, which is a little bit of a writing challenge, but hopefully the reader will see how these alternating stories kind of merge and converge at the end. It's very much about the post-pandemic era, climate change era, an era of political instability, global realignments that are happening on a daily basis. And at the same time, we're poised on the cusp of this era with new approaches to work, new approaches to knowledge, new approaches to intelligence. Sometimes I talk about it as a steampunk fairy tale that actually happened. And by looking at the historical stories, they're just alien enough to us that we can see new things in them. And at the same time, these were the people that invented the industrial world. And I actually have a whole chapter on why I'm not a fan of counting Industry 1.0, 2.0, 3.0, 4.0. I don't think that's a very meaningful set of distinctions. And at the same time, if you are counting, this book is about going from 0 to 1, and we're at a moment where we need to do a similar kind of reinvention. It is not a book about policy. We just did a book on the future of work that is about policy. There's a lot of policy happening and going on. The book is not full of statistics and graphs. It's really about the human dimensions of industrial improvement. And I'll read a little section from it. It's about the interconnectedness of work, industry, culture, individual action, and collaboration. It's about the relationship between thinking and doing, and the relationship between the world of ideas and the world of things. It's about class conflict, hot metal, linseed oil, pinched fingers, AI, and pistons sealed with donkey dung. It's about canals and mines and delicate manufactured tea sets adorned with ancient dancing nymphs, and about industrial systems as extensions and even mirrors of human society, and how both of them can and need to change together. In some sense, the book is really aimed at younger people who are working in industry, and showing them that they have an important role to play in changing the world. And that many of the people who are working, who are in the 18th century, who the book is also about, were in a world of very similar upheaval and uncertainty and great concern. And at the same time, they sort of put their heads down and made things, and that changed the world. Again, I think one of the real key word in the text is industry, because not only does it describe the things that we all study, but it's also a human virtue. And Benjamin Franklin was actually key in defining it that way, the sustained application of human effort to a particular goal. In fact, the industrious revolution, the change in how people worked, preceded the industrial revolution. It's also about manufacturing and industry as a basis for American democracy. And interestingly, the development of and transformation of US industry is one of the few things in Washington that both parties agree on. They don't agree on what policies should get us there, but they do agree that this is something that's important for the country. I didn't know who would win the election when I wrote this book, um, but it's really not about any particular set of policies, as much as it is about the importance of the relationship between product innovation, what things we make, and process innovation, how we make those things. So if you look at an image like this, you may see a kind of antiquated colonial image of a man from the 18th century, and it may look antique to you. Um, when I look at this image, I actually see manufacturing. And this was a style very much enabled by the industry of the time. This is an 18th century English gentleman's costume. But in addition to the stockings made on the famous Arkwright stocking frame, I want to draw your attention to the buckles on his shoes, the buckles on the hat, the buttons, and the sword that he's carrying, all of which were likely made by this man, Matthew Boulton. And Matthew Boulton was a toy manufacturer in Birmingham, uh, 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 in the Midlands of England in the 18th century. And in the 20th century, Birmingham gave the world J.R.R. Tolkien and Robert Plant from Led Zeppelin. But in the 18th century, Birmingham gave us what they called toys. And these were small, cheap metal objects. Um, again, buckles, buttons, actually guns were quite important there. Those were the most complex of the Birmingham. And Matthew Boulton was a leader in that kind of manufacturing. I'll read a little paragraph about him. Few can claim, as Matthew Boulton could, to have been present at the founding moments of the Industrial Revolution, to have instigated key elements, and to have imagined it in advance. Engaging, social, and matter-of-fact, Boulton possessed high technical skill in his trades and the humility to know when excellence had come to them. His curiosity both begat the Lunar Society and enabled him to see the future of industry. Entrepreneurial drive, coupled with a lack of pretension, gave him an eye for fashion and ability to sell his products to the social aspirations of consumers. He dressed kings and queens, and he helped common people dressed like royalty. One of my favorite Birmingham products was when aristocrats began wearing diamonds on their clothing around this time, at one of many colonial products that were enhancing consumption in Britain at the time. The Birmingham manufacturers in Boulton figured out how to take steel studs and polish them to such a shiny degree that in the low candlelight of a party, they would look like diamonds. And they sold those by the oodles and oodles, enabling middle-class people to sort of get some aristocratic flair. Very typical of both Birmingham and Boulton's approach to things. And Boulton actually, with his friend Erasmus Darwin, Charles Darwin's grandfather, began in the 1760s convening a group of friends that very consciously applied the principles of the Enlightenment. We're now talking about 50 years after Isaac Newton's death. The principles of the Enlightenment to the development of industry. They would mix what we would now call scientists, but were generally called natural philosophers. Joseph Priestley was a key member of the group. Benjamin Franklin was actually their inspiration, and Franklin came and visited them early on. They were all electrical experimenters. They would meet on the full moons, and so they called themselves the Lunar Society, so they could walk home late at night by the full moons. Although there was a little bit very self-conscious symbolism there. In fact, they refer to themselves as lunatics with a C-I-K-S. And so I'm trying to revive that term as a compliment. They met in this house, Soho House, which is the house that Boulton built with his factory, right on the grounds of his factory. The factory is long gone, but the house is still there. I was there last April. Really brought together a whole set of interests. And again, mobility was very key here because canal building was a big thing. And you couldn't have a factory without a canal. And all of the Lunar Society members who were manufacturers also invested in canals. And then all of their interests would feed back on each other because when they were digging canals, they would unearth fossils, which enhanced the conversations about natural history. And they would enhance minerals, which they would then experiment with and collect and classify to improve their manufacturing processes. Through this group, there was a guy named William Small who came in. And actually, William Small had just returned from a kind of not very successful teaching stint at the College of William and Mary in Virginia, which was a colonial backwater at the time. And by coincidence, the entire faculty had quit or been fired for drunkenness the year before Small arrived. So he taught every single class at that school for 2 years. And those happened to be the 2 years that Thomas Jefferson was a student there. And William Small was the man who taught Isaac Newton and all of the Enlightenment principles that Jefferson absorbed early in his life. And there are actually echoes of that teaching in the very first sentence of the Declaration of Independence and many other of Jefferson's writings. And Jefferson was very clear that he was very indebted to Small. But at the behest of Benjamin Franklin, Small went back to London. He didn't particularly like living in Virginia. And then Franklin said, you should go to Birmingham and see Boulton. And the two hit it off very well. And shortly thereafter, William Small moved to Birmingham, and they began gathering their friends. Small was a great connector and kind of party giver. And one of the first things that Small did, he was from Scotland, said, I know this struggling young instrument maker at the University of Glasgow who's got this great idea for improving a steam engine. I think you should talk to him. And that young instrument maker was named James Watt. And he quickly came to Birmingham, and he was struggling. He had a good idea for a separate condenser to improve the utility of a steam engine for pumping out mines. And as soon as he met Boulton and saw his factory, he realized that Boulton had something Watt was not going to get on his own: skilled workmen and experience and access to capital. But Boulton himself also realized Boulton had been dabbling in steam. He was very unhappy with the water power that was driving his factory. So he knew enough to know that this young man knew a lot more than he did. And very quickly, Boulton stopped his steam experiments and proposed a partnership to Watt. And Watt said, he brought it to his own investor, a guy named John Roebuck. And Roebuck wrote back and said, I'll give you a license to our steam invention for 3 counties around Birmingham. And Boulton writes back and actually rejects the offer. And the letter that he writes to reject the offer is a remarkable letter. And I'll read this paragraph to you. He says, well, starting at the bottom, it would not be worth my while to make for 3 counties. My idea was to settle a factory near to my town by the side of our canal, where I would erect all the conveniences necessarily for completion of engines, and from which manufactory we'd serve all the world with engines of all sizes. By these means and your assistance, he's writing to Watt here, we could engage and instruct some excellent workmen. So he's thinking about his workforce with more excellent tools than anyone could procure on their own, and execute the invention 20% cheaper than it would otherwise be executed. And with as great a difference in accuracy as there is between the blacksmith and the mathematical instrument maker. So this is Watt's problem. He's an instrument maker, and he doesn't know how to scale up his invention to the full scale, basically building sized steam engine. And this letter that Boulton writes to Watt, I think, in fact, this very paragraph, you could say, is the founding document of the Industrial Revolution. And all the young industrial entrepreneurs might study this paragraph, because in some way, Boulton sees the whole thing already, and much more than pumping out mines. And it actually takes 4 more years before they form a partnership. But eventually, Boulton's patron goes bankrupt. Boulton buys him out. Watt moves to Birmingham, and they begin building engines in earnest. And they begin building pumping engines for pumping out mines, which is what the existing Newcomen engines were used for. And at this point, Watt has actually been working on his condenser idea for 20 years. He's tired. His wife has recently died, leaving him with 2 small children. He's never been very solvent economically. And he's a kind of depressed character. He's actually even suicidal. Basically says to Boulton, okay, we've just sold 16 of these for the mines in Cornwall. We've busted our behinds making them work. I'm done. And Boulton drags him across the threshold of his own mediocrity into a world of excellence and says, no, this is not about mines. This is about running factories. And to run factories, I can't have an engine with reciprocal motion, which is what the pumping engines had. I need an engine with rotary motion. So you get yourself back to Birmingham and you make me a rotary engine. And kicking and screaming, Watt actually does that. And it's actually the next couple of years are the most productive of his inventing career. And I like this little schematic because it shows you actually the four inventions that Watt makes that make the steam engine a viable industrial product. And you can see it's a rotary engine. It's driving this big flywheel. There's the sun and planet gear over in the bottom right that converts the reciprocating motion to rotary motion. That's a beautiful mechanism, not by coincidence named after an astronomical phenomenon. Although mostly a way to get around a patent that had been issued for a crank, which is a normal way to do it, which they then replaced this mechanism when the crank was available. More important is the double action of the steam. There's a set of valves here, beautifully intricate valve gear that Watt invented, where the steam enters both above and below the piston in alternation. Simply doubles the power of the steam for a given cylinder and a given size. But requires a lot of precision machining that didn't exist at the time. Next is Watt's parallel motion, this intricate but beautiful mechanism up here, which enables the kind of rotary motion of the end of the crank here to both push and pull the piston up and down. When you're only pulling the piston up with half of the motion, you can use a chain, but that won't, of course, push it down. And Watt's parallel motion became very famous and well recognized. And then, of course, one of my favorites, the flyball governor, which is the first industrial feedback mechanism, which in effect turns the steam engine into a clock. It makes it a regular instrument. You can't have huge variations in power when the steam pressure goes up or down a little bit. That would break the threads in industrial textile mill, for example. And they actually deliver this engine, the first one in 1776. Same year, of course, as the American Declaration of Independence, written by Lunar Society influenced Thomas Jefferson. Same year as Adam Smith publishes The Wealth of Nations, which I'm quite critical of because I don't think he understood anything about manufacturing, even though he and James Watt were friends. And he never bothered to walk down the street and see what his friends were doing, and instead wrote about the pin factory in a very badly misunderstood way from a French text. That's a little bit of a icon of how economists have misunderstood manufacturing from really the beginnings of modern industrial capitalism. The first customers for this engine are actually breweries in London. The Whitbread Brewery is the first customer, and many other breweries follow suit. But this engine really becomes a kind of practical industrial product. And at the very least, the first thing it does is it removes the need to site a factory next to a canal or a waterfall or a waterway, although it does many other things for its customers as well. Now to bring us back to the present day, I think one of the previous times I talked here with Les Reynolds about the work that David Autor and she and I and many other MIT faculty did on the Work of the Future project, looking at where are we from a workforce point of view in the United States. And one of our conclusions was we don't have too many robots, we have too few robots. But this is a graph from that study, and it's a very well-known graph that the mean compensation in the US workforce has roughly followed productivity growth since World War II. But the mean is artificially inflated by those of us at the top of the income scale, and the median compensation really has not. And about 1980, there's this great divergence where the median compensation doesn't track the mean compensation. And one way to look at this as a robotics and automation point of view is, yes, robotics and automation has made the world more productive. And I include in that things like Microsoft Word, probably one of the most important, and spreadsheets and things. But who benefits and who gets those productivity gains? And here it's not been the American worker. A similar way to look at that problem, and this is from David Autor's work, is the hollowing out of the middle of the workforce. And again, This goes back to 2018, although I think it's still kind of true. Maybe it's changing now, but the biggest impacts were like 90s IT. Microsoft Word, basic, information technology, which really came into its own in the first decade of the century. And we all use it every day. And those are forms of automation of what used to be important job categories, particularly in the middle for administrative and office personnel, and other types of personnel. Those on the right side have been doing quite well. Good career ladders, good income, good mobility, socially and geographically. And surprisingly, maybe not surprisingly, the very lowest parts of the wage scale have been difficult to automate. Home health aides, fast food workers, retail workers, and the numbers have grown. Although the career paths not so much. So you end up with this kind of graph, which is pretty well known, and I've redrawn it, but it's not really my data or insight, but that the aging of the workforce and other pressures have really hollowed out the middle of the workforce. And you can see this right on the MIT campus, all over the MIT campus. My department, when I joined it in 1991, had 14 faculty and 6 or 8 full-time administrative staff just to do the kind of admin work to support those faculty. Today, we haven't grown much. We got about 17 faculty, and we have 1 admin staff to support the faculty because everybody does their own word processing and everybody does their own spreadsheets and email. But these used to be really fairly good career paths, especially for non-college educated women and minorities in particular, to move from country to the city, work your way up an employment ladder, and end with a fairly solid middle-class existence, income, retirement. Those have been largely hollowed out. They have not grown at anything like the rates of either the bottom or the top parts. Then what's interesting, and this is my work, if you look at what we might call technology readiness levels, where we have basic research at TRL1 to a kind of TRL10 of routine commercialization. And we're all familiar with the valley of death that so many of these technologies find themselves in. I think the intellectual moat around a place like MIT is even deeper than it ever was. It's more and more difficult to get technologies out into the world. But usually we draw the TRL scale from left to right, TRL1 to TRL10. And all I've done here is flip it around, a graphical change with no change in the meaning, and put TRL1 on the right and TRL10 on the left. And guess what? It follows almost exactly the hollowing out of the middle of the workforce. And who are those people in an industrial sense? They're senior operators, senior technicians, junior engineers, in the trades, in operations, in production. And in many cases, those are the people you need to rely on to adopt new technology. They're familiar with the daily operations. They're familiar with the process, whether it's in an electric power network or in a manufacturing setting or a subway system. And they're the ones who are the key portal to go through. And that corresponds to our howling out of this missing middle between pilot deployment and scaled adoption. And there are robotics companies all over Boston that are struggling with exactly that phrase, and mobility companies too, I might say. I like to use the word master chiefs because I used to work a lot on Navy ships, and the master chiefs are the senior enlisted people who really run the show. The junior officers generally don't know what's going on, and the master chiefs are the ones who run the show. And so the importance of these people in the middle is one of the lessons that the Lunar Society beautifully illustrates. One member was this guy, Josiah Wedgwood, a pioneer in pottery. Still to this day, my parents got Wedgwood pottery in 1958 when they were married. It's actually it was owned by a Chinese company. Now it's owned by a Scandinavian company. But for a century and a half, it was the greatest English pottery. And Wedgwood started as a potter, in a town called Burslem, not very far from Birmingham. And actually, smallpox, again, pandemics were part of their lives as much as they are part of our lives. Smallpox gave him a crippling infirmity that meant he couldn't sit at a potter's wheel all day. And that pushed him into thinking about science, innovation, design, and really a remarkable character, Wedgwood. And at the time, when he was kind of coming into his professional life, the English pottery was the lowest quality pottery in the world. And people said, you can't compete in the pottery business. Look at this Chinese porcelain. It's such fine material. They've been doing it for 1,000 years. There's no way you're going to compete with Chinese porcelain. And within 30 years, he had built an English native pottery industry that was the envy of the world, and sold Englishness almost as a product, both to the English people. Actually, one of his biggest markets was the American colonies. George Washington and all of his colleagues had Wedgwood pottery on their dinner tables because they wanted to feel English. And Wedgwood innovated in the division of labor. He integrated into what we would today call mass production. He very much innovated in marketing and sales. He sold pottery to Queen Charlotte, the wife of George III, who we would today call an influencer, and was very aware that once he sold pottery to her, everybody would want it for their own houses. If you ever think about if you've ever heard buy one, get one free, that's a Wedgwood innovation. Such an interesting story of a company. And Wedgwood was one of these people in the middle. He understood what the potters needed. He understood the craft of pottery. He understood how to make it more productive. But he also, and he had a partner who kind of was his ticket into the aristocracy, was able to talk to the ruling classes, the customer classes, the people with the capital, and also the people with the money who were buying his products. There's a similar story in the United States. This image on the left is a painting by John Singleton Copley, after whom Copley Square is named, right across the river from us here. It's in the Museum of Fine Arts here in Boston. It's one of the best known paintings in the museum. It's actually, Copley made his career painting clergymen and merchants and political leaders. This is the only painting he ever made of an artisan. And this artisan, you probably know the name, is Paul Revere, who played a major role in the American Revolution. But he was a silversmith. And one of the reasons he played the role he did in the Revolution was because he was able to speak to both his clientele, people who were buying his silver, who were the leaders of the revolution, and also the merchant leaders in the city of Boston, and the workmen who worked in his shop. So he played this kind of middle role. And after the revolution, much less well known, although my friend Rob Martello at Olin College wrote a great book about this, Revere was actually one of the earliest industrializers in the United States. He had what was the first contract from the new U.S. federal government to make copper sheeting for the U.S. Navy. He made the copper sheeting for the USS Constitution and the copper sheeting that originally plated the Boston, the Massachusetts State House, which is now in gold leaf, but it was originally copper sheet. And innovated in rolling copper, in casting bells, in casting cannons, and was very aware that manufacturing was a way to kind of express these values of the new republic after the country had been founded, and to contribute to building the community around that. And you can actually go still visit the Revere factory, which is in Canton, Massachusetts, just a southern suburb of the city today. There's a nice small museum, and of course, like everything, his factory is now a condo complex. So Revere was very much a character like Wedgwood, a kind of Enlightenment character on the border between these classes, but shows you the true importance of this kind of translational middle for the growth of industrial technology. So Junhua knows well about this, and in this same period, I've been writing this book after running my company Humatics for 6 years with an investor colleague of mine. We formed a company called Enlightenment that is designed to catalyze this industrial transformation in the US, with the kind of building on the idea that software has kind of driven a lot of how the venture industry has been run, and that the financial instruments that we've been relying on are very good at serving the software and now the AI side of the world, but much less good at helping industrial companies grow. And I just want to give you a couple of examples, and it's the images that I think that matter as much as anything, but a few of the companies that we work with. One is a company called Villa that's actually not actually building factories for homes. There are actually plenty of manufacturing facilities for small homes in the US, but there's very weak distribution channels to fill those houses in to a lot of the smaller spaces that cities have. So we're in a housing crisis in this country, and yet most of the housing industry is still organized around making McMansions, because that's the scale. McMansions in giant developments, because that's the scale that they can make it pay for. Using a lot of great innovative software and kind of transparency in the construction process, Villa is building many of these smaller dwelling units. Think of the ADUs, the auxiliary dwelling units, that are very popular in California and other places. They'll go to a condo complex built in the 80s and say, you know, the parking lot here is 3 times bigger than it needs to be. We can put 12 more units in the parking lot, including the parking, just using modern design methods and modern logistics. Vecna is a local company here that's spun out of MIT that's doing automation in warehousing and material handling. Really interesting company. And here again, the line between what's logistics and warehousing and what's manufacturing is almost invisible. Every factory has a warehouse, and factories are really just nodes in a mobile flow of goods. This is a really interesting one, Panthalassa, that's doing, this is actually the bay in the shipyard in Portland where the Liberty ships were made during World War II, and using very simple manufacturing technology, all sort of rolling 1/8-inch steel plate, which is a very common capability, to build autonomous floating power generation nodes that will create the cheapest green electrons on the planet in some of the most inhospitable parts of the ocean, where the energy densities are just ridiculously high. And it's an amazingly powerful way that really no one has taken advantage of, because all the ocean power work so far has been shore-based, which is very complex and not really where the power is. And you can see here, I like this picture because it captures the sense of young people, engineering graduates, working with hard hats, working with their hands, working in industrial settings, welding, and combining that with these Starlink antennas that communicate with it with this device. Sustainment is another really interesting one, a platform that really just connects. Think about like an Alibaba for manufacturing, but one that has secure supply chain built into it. And so, you know, this week particularly is the moment for a sustainment, because so many companies are scrambling to figure out how to reshore whatever they've been doing. And this company will take a drawing of a part for you, run it through an AI system that's been trained by retired machinists, and not only show you the necessary manufacturing process required to make the part, but actually show you the suppliers in your area, or according to whatever criteria that will make all of those parts, whether it's in your state or in your region, or, you know, in Texas, or wherever you'd like to search by. So all of these I use really as illustrations of what the later part of the book is about, which is a new industrialism. And that is to say, whichever party you're from, the policies are going to be ineffective if we don't have a cultural movement that brings young people into industrial systems, whether they're engineers or frontline workers or technicians or many, many different levels. But we need a cultural movement that enables people to see that changing the world need not be done either through creating an NGO or lobbying the government or protesting or writing op-eds, but actually making things is a crucial way to build and change the world, that all of these examples from the Lunar Society have done.
Much, David. Let me spotlight you here. Good. So, where's David? Let me add this. Great. Cool. Yeah. Yeah. Thank you again for really the fascinating story. Let me mention one thing. In the prior conversation we had, you said there are a lot of ideas that the Lunar Society people had that share with today's agenda, but also there are a few things that the Lunar Society people didn't do or didn't think about. But these are critical new agenda our generation adding. Can you elaborate, share with people?
Sure. Yeah, I go into this in some depth in the book. I feel like their industrial philosophy missed two things, right? At least two. One, labor, and one, the environment. Two, the environment. And these are two problems that were kind of built into the way that they imagined industry. They didn't really realize were problems. They definitely realized that labor was a problem, and they had some of their own environmental concerns. But they really didn't get it right. And that was a struggle for 100 years just to get people to come to work on the same time based on a clock every day. And they all struggled with that problem. Watt was a terrible manager. And then, of course, the impact and the relationship of the industrial systems to the earth that we live on, right? The steam engine, the original ones particularly, you can see them as a mediator between the earth and the human world, right? They were pumping water out of mines in order to extract resources. Even Watt and Boulton, when they went to Cornwall, already by the 1760s, that landscape was devastated by the mining industry, and it was post-industrial looking even at that time. So how do you think about a industrial system that, I won't say fixes those two problems, because I think the labor problem particularly is quite fundamental and has to do with the complexities of bringing crazy human beings like us into relationship with rigid technological systems. But there are places that do better with it than other places, and what can we learn there? And I'm clear about this in the book. I think there are companies all over the place that are doing this new industrialism. Not something I invented. I'm just trying to crystallize it a little bit. And there's lots of companies that are doing really, really well. There are companies that are competing in manufacturing internationally, but not enough of them, and not at a large enough scale.
Yeah, on that, related to the point of, you mentioned the hollowing of the middle, right? Both in the job sense, but also in the technology sense. For that, do you think that today's evolution, we are even moving toward the trend where even exacerbate that hollowing the middle, right? Anything we can take proactive action to resist?
Oh yeah, I mean, I actually think some of the ways that that universities are under attack are related to that problem. As I said, I think the moat around MIT intellectually is bigger than it ever was. I don't think MIT is defending itself as well as it should be in terms of making clear all of the contributions that have been made to industry by MIT and its spinouts over many years. We're still very good at feeding our graduates into the kind of coastal elite that we ourselves are a part of, much less good at encouraging them to either return to their hometowns or build the parts of the country that need to be reindustrialized. Some of that happens, but again, not at nearly enough of a scale for it. Our R&D systems are still way too focused on what's coming in 30 years and not focused enough on how to get the things we've already made out into the world. There's a long list of things we can be doing.
Right. In the book, you mentioned that the need for the new kind of industrialism that based on the scientific curiosity and the collaborative design. Do you think that ideal versus today's incentive structure, right? How do we fund a certain project? How do you measure success? Do you think the current incentive structure is conducive to that ideal?
Well, I think we can change the current incentive structure, and unless is trying to do that in a small way. And again, I think there's a lot to be said for kind of cultural movements in this regard. I think the STEM focus activities of the last 20 years have been fairly successful in that way. But it's still sort of, actually, one of the founders of one of these companies said to me once, in my generation, the elite were trained to climb ladders. They weren't trained to make things. And I think that's a pretty good summary of where we've come to. And how do we rethink training the elite to make things? And that's hard to do because, you know, most of us faculty don't know how to do it. That's why we like to teach theory and blackboards. How do we actually teach the elite to think about how to make technology work in the world?
Right. Indeed, for that, like John and I will talk a lot about academia need to acquire a degree of humility where many of the innovation come from the industry, come from the community, right? Bring it into the campus so that interact with this, right?
Exactly. Again, process innovation breeds product innovation.
Right.
That was the great conclusion of the 2013 MIT study that Suzanne Berger led.
Right.
You know,
on
and
that point,
the vernacular way to put that is ask the person who comes to your house to fix your dishwasher what the strengths and weaknesses of every dishwasher are. They will know that in their bones. You need that knowledge when you're designing the next generation of dishwashers.
Right. You know, that's such an important, when you talk about the story between Boulton and Watt, it's such a fascinating story, right? There are many ways to look at the relation, but one of them is in the book you mentioned, you can look at Watt as a product innovation person, while Boulton as a process innovation person. It's this union that makes it so powerful, right?
Exactly.
Yeah, and the US somehow is at the risk of losing such union here, right? So
we have already lost a lot of it.
Wow.
Thanks to Adam Smith's descendants who could never see that.
Wow, I see. And any suggestions for us to counteract that trend?
Well, there again, I mean, I have a whole chapter in the book about the phrase when you open any product designed by Apple in California, right? And how that embodies the problems with the thinking from the 90s about all manufacturing is just rote work that needs to go on in somebody else's country where we don't have to think about it. And what we've, of course, learned from China is that doing that manufacturing, the process innovation in that manufacturing leads to the product innovation. And by the way, that's not how Apple does it anyway. They have engineers in the factories in China all the time, understanding exactly what's going on.
Right. Last question from me before I give it to John is you mentioned that design a system that prioritize dignified, resilient, and a minimal environmental impact there, right? Tell us more about it. But if you can link it to a mobility or transportation example of that.
Sure. I mean, you know, again, some of these are just basic lessons from the pandemic in that companies optimize for low cost, but often that's not a risk-adjusted cost for disruption to a global supply chain. What does it look like when you optimize for resilience, or when you price supply chain disruption into your optimization? We all know, and we all teach this at MIT, you can't optimize without optimizing for something. And that choice of what you're optimizing for and how you describe it is crucial. You know, again, what does resilience look like? There are many people here who work on that. I think about Yossi Sheffi. I drew a lot on his work for the book. But you know, these are some fundamental ideas in how we need to think about industrial systems in a very broad way that are just beginning to get out there.
Thank you, John.
David, very early on in this presentation, Wendy Silvani had raised the question, how do you define the word industrial at this point in time, and how has it evolved? I want to start with that question, and maybe by extension, how do you define the word reindustrialize, which obviously is becoming very popular? And just to contextualize, just a quick story. So yesterday, Jinhua Buvan and I were visiting a company across the bay in San Francisco in Alameda called Navier. Navier is an electric boat company that was founded by a woman, Samprati Bhattacharya, who got her PhD in mechanical engineering from MIT and has built this company that is building and delivering electric boats with a team of about 20 people in the Bay Area. And it was fascinating to hear her talk about the challenges in the industrial supply base that she's confronting. Carbon fiber design of these hydrofoils. Where is the capacity to do that in the United States? And it's extremely hard to find. And what limited capacity there is, the people who know how to do this are all sort of sucked up by the aerospace industry. So with that as kind of context, and when we think about, how these capacities to design certain products exist all around the world, but particularly in China, and at the scale that has been established in China, how do you think about that word reindustrialize in the US context?
Yeah, I mean, that's a great question. I mean, I define the word industrial not in a rigid sense, but I just say, industrial systems are the systems that that are spread throughout our economy to provide basic human needs, and food, shelter, mobility, actually included social status as one of the basic human needs. That was something I learned from writing this book, was how much the consumer desire for social status was a driver of these early industrialists. And on the one hand, that's a definition that could include almost anything, but I don't really include healthcare and financial systems, even though they're legitimately called large-scale industrial systems too. Reindustrialize is an interesting one because no one thinks we can or should be manufacturing everything here in this country. In fact, I have a friend who is a dish importer, and he's actually a big fan of Wedgwood, and so that's an interesting one. Like, we probably shouldn't be making like simple ceramic dishes in the United States. It's just not going to be effective for us for a lot of different reasons. That just raises the larger question of what should we be making here? And again, that's probably a better one for markets to figure out than for professors. But there is a kind of broad agreement that advanced manufacturing, however you want to define that, and that building the next generation of various critical items is important. There's also the national security dimension of certain things that are fully domestic. I mean, Ben Armstrong tells me that the only truly domestic manufacturing supply chain is actually submarines, and where every last component is domestically made. But even within the DoD, there's very few that can make that claim. And so, but you also, if you're a navier, and you can think about product design. We're not quite there yet with the product design tools, but I think they'll get there, where if I choose a part, or a component, or even a machine part to go into my new design, I can instantly see a picture of a supply chain that could potentially supply it and identify those at design time. And what I'm really designing is not a device itself. I'm designing an industrial system that creates and delivers that device.
Well, I'm going to tie this into an almost impossible task in 30 seconds, because James Natter added the question, will the recent tariff announcements really lead to reshoring of manufacturing and industry in the US? I know this is this is really unfair of me, but is there any way you can sort of take a stab at that?
Well,
what's the situation?
I think they won't without investment, right? And what kind of investment that is? Unlikely to be government investment from this administration, but there still needs to be a great deal of investment to make that happen. And B, it can't happen without a generation of young people deciding that this is important and a good way to spend their living and their time and their work, the best of their work years. And that second one is really the part I'm trying to address with this book, is teaching people that if they do that kind of work, they're part of a grand tradition. It's an important way to change the world. Actually, in the Wedgwood case, I didn't say much of it here. There are very important social justice outcomes that came from his work. In fact, he was a key member of the movement to abolish slavery in the United Kingdom through making ceramics that supported the cause. And so whatever you want happen, again, both parties agree on the goal. They don't agree on the means, but any policy is going to be empty without this kind of major social movement.
Excellent.
Great. It's at 1 o'clock. Thank you so much again, David. This is such a fantastic historical lesson, but also such much kind of relevant to today's discussion, right? David, if you don't mind, stay for a bit with the breakout room. We'll talk a bit. But for the audience, I do want to announce the next week, we have a mobility forum sub-series called Women in Transportation. We have 4 women leaders who will join us. Hyana Park, Sam Pariti, who is the CEO of the Navia company that John David just mentioned, Robin Chase, the founder of Zipcar, and Christine White from Google mobility policy side. So hopefully see you, more of you next Friday, and have a good weekend. Please also join me, thank Professor David Mindell for the presentation and conversation today. Thank you.